A very good morning, children. And up to yesterday's session, we had learned the concepts completely regarding the solid state. And it is one of the physical chemistry part we went on now. We are switching for one of the organic chemistry part, that is with amines. Regarding to CET, from the diazonium salts, the topic is not there. But for neet, it is there. Means complete concept is there for the neet. No topic was deleted from the chapter. So presently, once we start the concept, what is meant by an amine? We know ammonia. What is ammonia, children? Ammonia formula is NH3. Ammonia formula is NH3. If you replace one of the hydrogen from ammonia with any alkyl group or aryl group, if you replace one of the hydrogen with an alkyl group, we call such kind of compounds as the amines. What do we call such kind of compounds as the amines? One of the hydrogen from ammonia are replaced by alkyl group. It is called as an amine. But only one alkyl group if it is replaced, we call this one as a primary amine. If you are able to replace two of the hydrogens, then we call this one as a secondary amine. If you are able to replace three of the hydrogens from the alkyl group, it is called as ammonia. It is called as a tertiary amine. So the classification of amines also is covered here. Means primary, secondary, and tertiary are there. These amines, once you see the structure, the amines like the primary amine taking. If you want to see the ammonia, basically, in the ammonia, generally a question will be given from the P block also, including what will be the hybridization and also what will be the shape of the molecule. A common question will be there. So in order to find out the hybridization, you can use this formula, children. Hybridization. The formula what you can use is half of monovalent atoms plus valency minus charge of cation plus charge of anion. What is this M? M stands for monovalent atoms. Monovalent atoms. V stands for valency. C stands for charge on cation. If charge on cation, A stands for charge on anion. Charge on the anion. Negatively charged and calling as the anion. Means if the molecule is having a charge, at the time you can consider the charge. So first of all, what is hybridization of NH3? Hybridization of NH3, we can say how many monovalent atoms are there. What are monovalent atoms which can form only one bond? Like hydrogen, especially we will consider, or the halogens we will consider. These are coming under the head point called as the monovalent atoms. So here how many hydrogens are there in case of NH3? 3 hydrogens are there. So monovalent atoms are 3. Valency of nitrogen. If you see the atomic number of nitrogen, it is 7, and you can write this as 2, 5. Means how many valence electrons are there? Outermost valence electrons are there, means 5 electrons are there. So regarding this one, you can say half of 8 is nothing but 4. So these numbers what we got, we can apply that to decide the hybridization. If the number is 2, it belongs to sp hybridization. Number is 3, sp2 hybridization. Number is 4, sp3 hybridization. Number is 5, sp3d hybridization. Number is 6, sp3d2 hybridization. So these are the shortcuts to find out the hybridization. Whoever is working parallelly with the chemical bonding chapter, they can use this formula. Good. Now we came to know what is the hybridization of these amines. Here there is no much change. The only change is with hydrogen. Amines also will have same hybridization. What is meant by same hybridization? 4 refers for which hybridization? 4 refers for sp3 hybridization. In general, if there are no lone pairs, sp3 means you can say tetrahedral. But here, due to the presence of lone pair, the molecule is attaining pyramidal shape. The molecule is attaining pyramidal shape. So that's what about the structure of the amines. Structure of the amines was illustrated up here. And coming for nomenclature, already the nomenclature is in detail explained for you in your classroom. How to give name. So you please read the entire textbook regarding the tabular data is there. How to give naming in the aliphatic amines and how to give naming in the aromatic amines. Now I am not teaching that point again. Okay, good. But here we are going for the next level. Once we cover this introduction, we can go for the nomenclature of the amines. The next concept is regarding their preparation. Generally, these amines will exhibit some isomers. Amines will also exhibit some isomers. What are the isomers the amines can exhibit? For example, they may question you like, what are the isomers C3 H7N is exhibiting? C3 H7N is exhibiting. You people please remember, children. Here, where the user means C3 means how many carbons are there? CH3, CH2, CH2, NH2. See how many number of hydrogens we got here? Better it will be C3, 1, 2, 3, 3 carbons are there. Hydrogens are 5, 7 and 9. So let me correct the formula is C3H9N. So in this C3H9N, one of the isomer, first thing whenever they ask the question regarding the isomers, you write the carbons in straight chain. Try to get the carbons in the straight chain. Then try to get a branched carbon. In the next level. So regarding the chain, we had completed. Means these are called as the chain isomers. We can call as the chain isomers. Now, in the first case, hydrogen is at the last position. Now I am bringing the hydrogen somewhere at the middle position. NH2, CH2, CH3. I am calling this one as the first structure, second structure, and third structure. What I am giving is CH3, NH, CH3, CH3. So this is what the one more isomer. In this, we can see the position of the nitrogen is changing. It is at the first carbon here, whereas in this it is at the shortest carbon chain. We need to find out the second carbon. Here also it is falling at the second carbon. So first thing is these three are positional isomers. What are these three? Positional isomers. These three are the positional isomers. Whereas the first and second, once you see, they differ in their chain length. So these are following the chain isomers. So for C3H9N, how many isomers are possible overall? Totally there are 4 isomers that are possible. So the amines, they show both positional isomers and also chain isomers. Let us see the preparations of the amines now. Let us see the preparations of the amines here. Preparation of amines. How we can prepare the amines? There are many preparations, children. First thing, we are taking from ammonia. We are taking using ammonia. If you react ammonia with hydrochloric acid, what we can get? We can get ammonium, or I would like to say, better you can use alkyl halide instead of ammonia. Alkyl halide I am using. Alkyl halide acetate. What it can form? It can form NH2. It is able to form a primary amine by removing HCl. So ammonia first is reacted with the alkyl halide to form the primary amine. This primary amine is further reacting with an alkyl halide. This further reacting with the alkyl halide. So the lone pairs that are present here, will be involved in donation of the lone pairs to the alkyl group, which is electrophilic in nature, and that results in the formation of the secondary amine. Whereas one more step, if you continue, means if you react with one more molecule of alkyl halide, you can get the tertiary amine. Tertiary amine, once you further react with one more molecule of alkyl halide, it will give the quaternary ammonium salt. What is it giving? Quaternary ammonium salt. So primary, secondary and tertiary. Here the problem is we are getting mixture of amines. What are we getting, children? Mixture of amines. So it is difficult to separate the amines. You are using some alkyl halides like CH3, Cl, CH3, Br and CH3 iodine. Methyl chloride, methyl bromide, methyl iodide. It really how or which one will have more reactivity in the group once you see from top to bottom. As atomic radius increases, bond and alpha will be low in case of methyl iodide. So alkyl iodide is more reactive. Than alkyl bromide, which is more reactive than alkyl chloride. So they may ask the order of reactivity of these alkyl halides also. So this is what the first preparation we have seen from the ammonia. We are seeing the one more preparation. See, one more point I would like to highlight here itself instead of taking for the next point. RNH2 we are having, right? RNH2. I am writing this method. What is this one? I am calling as a primary amine. Generally, if you see the properties, which properties? Physical properties. Introduction after this preparation will be having with the physical properties. Once we see the physical properties, there they are speaking something about the boiling point. I will not repeat the concept again here. Under the physical properties, they will highlight a concept that's called as the boiling point. In general, the lower amines are gaseous in nature. Lower are gaseous. From carbon number 3 onwards, they occur in the liquid state, and carbon number 5 above, they may occur in the solid state. So liquid means generally liquids will have the boiling point. See the point here, children. When you see in the primary amine, how many hydrogens are available? 2 hydrogens are available. Due to this number of hydrogens, 2 hydrogens are present. If I take another primary amine, here it is able to show 2 of the hydrogen bonding. Means primary amine, due to the presence of 2 hydrogen atoms, it is involved in 1 hydrogen bonding, second hydrogen bonding with this. Its lone pair will be involved with some other bonding. So hydrogen bonding will be more. But if you take a secondary amine, R, N, R, hydrogen. Here I am speaking that in this case of secondary amine, only one hydrogen is available. Please see approximately 2 hydrogen bonds were formed. Then here only one hydrogen bonding will be involved. But in the case of tertiary amine, the case of the tertiary amine, do they will be involved in hydrogen bonding, children? What is hydrogen bonding? The bond formed between highly electronegative element lone pairs and the top hydrogen of another molecule is called as the hydrogen bonding. In case of tertiary amine, due to lack of hydrogens, they are not involved in hydrogen bonding. What is the point regarding to boiling point and hydrogen bonding? See, the hydrogen bonding is directly proportional to boiling point. Means when the number of hydrogen bonds increases, boiling point will also be more for that compound. Okay, I will give one question at last. Now presently we had interrelated concept regarding the boiling point. From the physical properties of this. Let us see here now the next preparation of these amines. Once see the question here, children. One of the questions is given like, which one of the following has highest boiling point? Option A they have given CH3, CH2, CH2, NH, CH3. Right? Means here how many carbons are there? 4 carbons are there. And then we have one of the nitrogen here. Now option B. What type of amine is that? I want the point. What type of amine? When a nitrogen is bonded directly to two of the carbons, it is called as a secondary amine. And coming to the option number B. CH3, CH2, NH, CH2, CH2. Here also nitrogen is bonded to two other carbons and this is also a secondary amine. Coming for option number C. CH3 twice NH. Means this can be written in the form of open structure. The nitrogen is bonded to two methyl groups. Then it is bonded to CH2, CH2. Here nitrogen is bonded to 3 carbons. Hence this is a tertiary amine. Option D. 1, 2, 3, 4 and the nitrogen is there. In that case, this nitrogen is bonded to only 1 carbon. Hence this is a primary amine. So you decide which will have more boiling point. So by seeing itself we can guess it. We can now conclude our primary amine is having 2 hydrogen atoms, so it is involved in more number of hydrogen bonding, hence it will have more boiling point. Okay children, let's see here about the next preparations. What preparations we know very well according to the textbook once we can follow. Then we will go beyond the textbook after studying about few examples. So the second preparation if you see, what is the second preparation we have? We have the second preparation like nitro compounds on reduction of hydrogen in the presence of the catalyst like palladium. That is reduced to aniline. Or you can use the same nitrobenzene. At times it will be given like the formula C6H5NO2. You are practicing about the cyclic form. At times you must remember the formula also. If you can react this with tin in the presence of HCl, the same product will be obtained. Aniline will be obtained. It is also written as C6H5NH2. But instead of taking tin in the presence of HCl, they will use iron in the presence of HCl. This iron is called as a scrap iron. In this reaction, the FeCl2 that is formed will be hydrolyzed to give HCl. Means we can place less amount of acid, so cost of maintenance will be less. So it is much preferred. Scrap iron with HCl is much preferred in the preparation of the aniline or the reduction of nitrobenzene to aniline. We have the third preparation. What is the third preparation? We know very well. We know that are C triple bond N. What are the C triple bond N compounds called as? These are called as the nitrites. What do we call as the nitrites? Nitrogens can be reacted in the presence of sodium in the presence of, hydrogen in the presence of nickel catalyst, and along with that we are using sodium amalgam and ethanol as the solvent. Sodium amalgam and the ethanol as the solvent. Then the nitriles are reduced to the corresponding amines. Reduced to the corresponding amines. Whereas you can use the amides also. Amides. These amides you can react with lithium aluminum hydride, which is the strongest reducing agent, followed by hydrolysis. Then the amides are reduced to the corresponding amides. These are very two easy reactions, is it not? Let us see here the next preparation, Gabriel thalamide synthesis. Followed by we will see Hoffman bromide degradation also. In the case of Gabriel thalamide synthesis, thalamide synthesis. What are the raw material we are going to take? Second raw material we are going to take thalamide. We are going to take the raw material thalamide. This is what we call as the thalamide. The thalamide we are going to see on the nitrogen low pairs are there. We are going to react this one with potassium hydroxide. So the OH and hydrogen will be removed in the form of the water, and that is forming a potassium thalamide. It is forming a potassium thalamide as one of the intermediate. After this is the crucial step. What is the crucial step here? We are going to take one alkyl halide. The alkyl halide, I am going to take alkyl bromide. Please see here, in this case, whatever alkyl halide we are using, the same product will be obtained. In this case, we cannot use the phenyl chloride or phenyl bromide, or aryl halides cannot be used. What cannot be used, children? Aryl halides cannot be used. Why aryl halides cannot be used? The benzene group being a self-nucleophile will overcome the repulsions with the nucleophile. So the condition is, with Gabriel thalamide synthesis, you can prepare only primary alkyl amines. In the first condition. Second condition, you cannot prepare aryl amine. That's a simple condition here. Then, what is the next point? We know the product that we are going to get is an alkyl thalamide. We got this alkyl thalamide. We are going to react with sodium hydroxide. 2 moles of the sodium hydroxide. Then here the sodium hydroxide will be donating the electrons. Sodium oxide will be giving electrons to the carbonyl group, which is the electrophilic in nature, and that results in the formation of phthalic acid. And our remaining part is there, right? Or the remaining part, this one, R and H2. So that is our product that we are able to get. So which kind of alkyl amine we are able to prepare? We are able to prepare the primary alkyl amine using Gabriel thalamide synthesis. So don't forget the reagents here and the condition that cannot be formed. Aryl amines cannot be formed. So let us see the next one, that is called Hoffman bromide degradation. What is the next one, children? Hoffman bromide degradation. So if you see the Hoffman bromide degradation, Hoffman bromide degradation means what? You are very important questions will be coming in this area. You are going to take one amide RC double bonded O NH2 is called as the amine, and you are going to react that with bromine in the presence of 4 moles of sodium hydroxide. Don't forget these two combinations. Now degradation means carbonyl group will be removed and the R will be bonded with the NH2. It is converting into a primary amine. Two of the bromines are removed with sodium in the form of the sodium bromide. And Na2 is left over. Na2CO3 plus 2H2O is the byproduct. Very important named reaction for the preparations of organic compounds. Write down this one, children. Now I will give you some MCQ questions. You can practice them. See this question, children. Whoever are preparing for JEE mains, this type of questions will be observed. Very application type of questions. We will not see how we got the same like NCERT. One reagent is given here. What is the reagent? Benzene is there. Further, the bromine is bonded. Along with that, the line representation we can see this point is CH2. For the CH2 there is chlorine. And the reactant is this one. The reagent is given as ammonia in the presence of ethanol. Ethanol is also mentioned as ETOH. ET means ethyl group. C2H5. Now, whenever we use ammonia, here if you study, in this case the bromine is involved in conjugation with the benzene. Bromine being a halogen having lone pair, it is involved in conjugation with the benzene. So you cannot substitute it. Then what is the another chance? We have the CH2Cl. So observe Rx means how have we mentioned? We call it as a alkyl halide. What will happen when ammonia is reacted with alkyl halide, children? When ammonia is reacted with the alkyl halide, that will form primary amine. The same it is there. This part is like the alkyl halide, and once you go on adding the here chlorine, how we had Rx here in the place, this is considered as the completely R group and this is the halogen. So we got the substitution here. Hydrogen was removed with the halogen. Similarly, the hydrogen will be removed with the chlorine. And the NH2 will be bonded to this part. So we got the product like names will not be given for these products. Children, names will not be given. You must find out the point where the reaction is taking place. I hope you understood. So you must identify halogens that will bond to benzene will not be involved in any other nucleophilic substitution reaction because they are involved in the resonance. So the remaining alkyl part is reacting with ammonia. How ammonia is to react with alkyl halide. Write down this question, children. Find out the answer. Option A. Here NH2 we got alkyl group, NH2 is there. Option B. CH2Cl, NH2 is there. Option C. CH2NH2 Br. Option D. CH2NH2 OET. What is the correct answer? Find out the correct answer. We got this one as the correct answer. Write down. We are taking the next question. See, children, one question is given here on the board like, which one of the following is tertiary amine? Whenever we get the word tertiary, it means the central atom, whatever we are studying it. In case of primary amine, what did we mention? Amine. We mentioned NH2. Similarly, in case of tertiary amine, what did we mention? R3N. Means the nitrogen is bonded to 3 of the alkyl groups. But here the point is not with amine, it is with amide. Means what? Nitrogen must be bonded to 3 carbons. Nitrogen must be bonded to 3 carbons. You write down here, I will help you once. These are all the line representations. In the examination point of view, they will give in the line representation only. You can see the option A. Here you can start like CH3, CH3. Next line is the CH2. The next one is the CH2. Next we have C double bonded O. C double bonded O. This bond represents the bond for nitrogen, and this got another chain CH2. Last one is the CH2. The next one is also CH2, CH2. So the option is directly saying here itself. Also first option you see nitrogen bonded to 3 other carbons, which is having some amide group. Which is having some amide group. We call as a tertiary amide. We call it as the tertiary amide. Means my suggestion is you must practice the line structures. You must practice the line structures. So write down the next question, children. See the question here, children. The question is given like this. In the given set of reactions, 2 bromopropane is going to be reacted with alcoholic silver cyanide followed by heating. It is forming some product X, and further it is reacted with lithium aluminum hydride, and it is forming the Y product. The IUPAC name of the product is, product means final thing we need to call. We need to find out this IUPAC name. So once we are able to understand what is the nature of the reagent, means what is the nature of this reagent, what work it is doing, then we can get the product. So let us see here 2 bromopropane. Let us get this in the form of equation, children. 2 bromopropane means how shall we write? Is this not 2 bromopropane? This is called as the 2 bromopropane. Now, after writing this 2 bromopropane, what the first reagent you are using? Alcoholic silver cyanide. Alcoholic silver cyanide. Do you remember, children, in the chapter haloalkanes and haloarenes? Once we use alcoholic silver cyanide, the halogen will be replaced by isocyanide group. Halogen will be replaced by the isocyanide group. Don't forget that. Very important. Most of the children will be writing as cyanide, Cl, but it is isocyanide. It is the isocyanide. So this isocyanide that is formed in this case, which is the X, here CH3 this is. You are reacting that with lithium aluminum hydride. Lithium aluminum hydride is a very strong reducing agent. Isocyanates will be reduced to the corresponding amines. Will be reduced to the corresponding amines. Isocyanates will be reduced to the corresponding amines. Now, what will be the IUPAC name? In the IUPAC name, longest carbon chain we need to find. What is the longest carbon chain? 1, 2, 3. This is the longest carbon chain. So, based on this, you try to study the names. N-isopropyl methanamine. This is isopropyl whenever you get. Yes, correct. This is isopropyl only. But that is a common name, not IUPAC name. N-methyl propane to amine. Can you see here? For this nitrogen, what is there? Methyl is there. So we can say that is N-methyl propane to amine. For the propane, exactly they have mentioned the position second one. So whenever you go for the IUPAC, the suffix must have the IUPAC numbering method. Prefix will have N-propyl or N-gamma if there are 2 methyl groups. I hope you understood, children. You must not forget the work of reagent. Read the question answer. Let us see here one more question, children. First question you can clearly answer. There is no surprise here. What is the question given? The product formed in the reaction is CH3 C double bonded O NH2. What is CH3 C double bonded O NH2 called? CH3 C double bonded O NH2 is called as the ethane amide. What is the full name? It is called as the ethane amide. Don't forget the name. Because once you know the name, it will be very easy. Ethyl amide plus bromine plus NaOH. Everyone knows what the product. It will be converted into the presence of bromine. Once you get, it may be NaOH, or you can use potassium hydroxide also. Any one we can use. 4 moles. Any one will be taken as 4 moles. The product will be CH3NH2, means methane amide. Methane amide plus byproducts. You know what are the byproducts? 2NaBr plus Na2CO3 plus 2H2O. The names are also very easy, but come to the application. See the question how this is given as. Some structure is given for the benzene. For that, I am not writing the product here. For the benzene, the point indicates it is the CH2 group. CH2 group. This is a double bonded group, and NH2. NH2. Okay, children. Whenever we go for numbering 1, 2, in that method we will start with the carbonyl group. So for the second group, carbon phenyl group is present. So it is called as the 2-phenyl ethanamide. What is it called as the 2-phenyl ethanamide? What is the difference between the above and below one? One of the hydrogen is substituted with some group of atoms. But the reagent what are they given? Bromine in the presence of potassium hydroxide. It may be bromine with sodium hydroxide, or it may be bromine with potassium hydroxide. The concept is with which name reaction? Hoffman-bromide degradation. Good. Now here, carbonyl group will be removed. Carbonyl group will be removed, and in that place, what will be bonded? NH2 will be bonded. What will be bonded, children? NH2 will be bonded. So generally, if it is there, CH3 NH2 is there, we have it presented as only methane amide. So longest carbon chain will also start with a methyl group here. So we will start with 1. For that one, what is bonded? Phenyl group is bonded. So 1-phenyl methane amide. What is IUPAC name? 1-phenyl methane amide. Don't be afraid of seeing the reactants. You think about the reagent, then you can get the answer. See this question, children. See, children, whatever questions I am giving, they are from the different models that are given in the previous years. So by that we can understand is it a direct question or indirect question. Once see the question here. In a set of reactions, meta-bromobenzoic acid gave a product D. Identify the D. What is the formula of meta-bromobenzoic acid? Already we had mentioned this one. It is ortho and meta-para. We know the positions. At the meta position to the benzoic acid, bromine is there. Hence it is called as the meta-bromobenzoic acid. It is initially reacted with thionite chloride. It is now introduced into the chapter carboxylic acids. I hope you had already revised the chapter carboxylic acids. At the last, carbonyl group. Once we see in the carboxylic acids, thionite chloride does not have any effect with bromine, because already we brought this type of example in the initial example. Because bromine is involved in conjugation with the benzene ring, it cannot displace anything. So the only point it can displace is with the oxygen OH group of the benzoic acid. So what we are able to get here is C double bonded O, Cl and Br. Thionyl chloride SOCl2, it replaces the chlorine from the benzoic acid. Next, this is what our product B. Our product B. I did not explain this point still, but we know once we react with ammonia, it is giving bonding to the electrophilic center of the carbon. And the hydrogen and the chlorine will be removed in the form of the HCl. Forming a product of C double bonded O. Here it is now. I am changing the position. Sorry. C double bonded O NH2. C double bonded O NH2. Don't forget acetylation or acylation of ammonia. Will give amines. That is one of the last chemical property. Presently, I didn't went up to that, but you know. It is already revised So amide, acyl or aryl or acyl, chloride on reacting with ammonia, what will be formed, children? Amide will be formed. That's what the product form. So this is the product C. So the C, after reacting with NaOH and Br2, blindly you can work with wherever sodium hydroxide and bromine are there. Here you have amide. What product you will have? You will have a product, a reaction. Which reaction? Hoffman bromide degradation. Hoffman bromide degradation product. What will be the product, children? NH2Br. Find out the product from the given options. You can see where the option is. I will not explain where the option is because options are there. You must understand. For the adenine, at the meta portion, bromine must be there. For today, I am stopping here. In the next class, we shall deal with the remaining concepts. Thank you, children.